Hi, this is Professor Hui. I'm teaching a course on energy. So the question we want to ask today is, what is energy? Here and now, we have plenty of energy surrounding us. And first, you have the sun, which is the most powerful source of energy. That actually is a nuclear form of energy that combines hydrogen atom into helium and thereby releasing a tremendous amount of heat and also light. It travels a long distance and comes to us in the form of light, and we have a very powerful source of energy, which is solar energy here. Now, if you take a little bit of time and you can sense also, besides light energy and heat energy, we also have wind energy surrounding us. And you can just look at the tree waving in the wind. And wind actually is a pretty powerful source of renewable energy that we can have. Now, all these heat and wind, and also if you see all around us on the road, there are cars running around. That is manifesting a form of energy called kinetic energy. For example, I have a bead here, and if I move the bead, it's moving away from me at a particular velocity. And so we also have kinetic energy. And I'm going to give a formula here. The energy of the bead is equal to 1/2 of its mass times the velocity squared. Now, this was discovered by Galileo and Newton and other people. And they also found that this first definition of energy also follow a form called conservation of energy. That basically energy of any different kind of forms here, light, heat, wind, and also kinetic energy is convertible from one form into another, whereas the total amount of energy in these systems is preserved. Now, there are other kinds of energy besides kinetic energy that we talk about, E equal to 1/2 of mv squared. And in fact, heat, as well as wind, is a different manifestation of the kinetic energy of matter, which we're going to explain later on in the course. But there are other forms of energy which we call, besides the kinetic energy, being the potential energy. And as the term suggests, potential energy is really energy that has potential to transform itself into kinetic energy. And in this potential energy area, first of all, we will have gravitational potential, which in this case here, we are putting the bead high relative to the ground, and if we drop it, what we find is that the gravitational potential of that mass is converted into kinetic energy as it travels downward. So we have gravitational energy. And second is also we can have magnetic potential. For example, we have here a magnet, pretty strong magnet, and I have some of the magnet that is encased in this styrofoam. And what you see is that basically, given that it's far apart, they attract each other, and therefore the magnetic potential is now converted into kinetic energy as a magnet fly towards the other magnet. The third kind of potential energy we call electric potential, which you see sometimes when there's a thunderstorm, you can see lightning is a form of electrical energy. The fourth kind is chemical potential. For example, here we have a whole bottle of alcohol, which is storing a form of chemical energy that's very often used as we try to create heat or make motors to work. Now that we've described 7 or 8 kinds of energy, we're going to talk about converting one form of energy into another form of energy. The first form of energy would be light converting into heat, as we put a match at the focal point of light. You see basically it ignited, and I can use it to light up the alcohol and then convert that into, now it's burning, even though you can't see. And then I put it at the, and I try to heat up. So we can also convert heat energy into motion by having the lighted alcohol heating up some air inside the Stirling engine. And if you look at it, you'll be able to see basically the engine is running based on the conversion of heat into kinetic energy. So we have shown how you can use heat by running a Stirling engine to transform that into kinetic energy. Now the third way we're going to convert one form of energy into another form is through light to electric. Now what I have here is a Fresnel lens that concentrates sunlight onto this photovoltaic chip, for which you can see right here that is generating a voltage of about 3 volts as well as almost half an ampere, producing a particular power by converting sunlight into electric energy. Now the fourth kind of conversion, we're going to do light energy and convert it directly into heat. And what you see here is a parabolic dish that concentrates sunlight onto the focal point, and then you can see literally steam is coming out of the after it passes through the coil, and then here then we can produce steam. Later on we're going to convert that steam into kinetic energy and then electrical energy through the use of a generator. So this course is going to be divided into 3 parts. The first part, we're going to talk about what is energy and describe in full details the equations involved in defining these forms of energy. The second part, we're going to look at the scientific principle of how one form of energy could be converted into another form of energy through studies such as thermodynamics or photovoltaic conversion. The last part, we're going to talk about the technology of energy conversion as well as the science, beyond the science, also the social issues about energy conversion. So join me in this lecture series and learn all you can about energy.